In this lesson, Glimmergrove survives a complete application restart. Continue is disabled when no valid slot exists. We save Rilfin, current resolve, the hearth Waymark, the bond house, and one exact position. After closing and reopening, Continue rebuilds those facts and returns the player to the same room. We will not merely call JSON stringify and hope. We will define ownership, validate a strict schema, verify a temporary file, keep one known, good backup, reject damaged data without partial mutation, and prove the complete root in Godot. This is episode 12, and it also works as a standalone beginner lesson on trustworthy local saves. Our player promise has 4 parts. Continue means a complete valid snapshot exists, not merely that a file name exists. A real process restart restores every visible fact we claim to save. A corrupt primary may recover from one validated backup. If neither file is valid, loading fails without changing the running session. We are not adding multiple slots, cloud sync, accounts, encryption, or mid-battle saves. One small local contract is enough to learn the hard parts correctly. Close Godot. Duplicate the Chapter 11 project and name the copy Glimmergrove_ch12_saved_slice. Open project.godot from that copy. Series viewers can use Chapter 11 as the starting project. Standalone viewers can download both checkpoints below. Use Godot 4.7.1 stable and compatibility to match the course. Never build a save system inside your only known good project because save bugs can be difficult to separate from older gameplay bugs. Before adding files, run the old route. Start a journey, choose a companion, earn the hearth Waymark, return to the village, and read one reward-aware dialogue. Then run the Chapter 11 validator. A save system should serialize a proven session. If battle result ownership or story flags are already unstable, persistence will preserve confusion rather than fix it. We need 3 terms. Serialization converts runtime state into plain data that can be written. A schema version identifies the exact fields and rules expected by one save format. A verified replacement transaction writes a temporary candidate, reads and validates it, preserves one valid backup, and only then replaces the primary slot. None of these words require advanced computer science. They are names for protecting the player's time. Draw the ownership chain. Main knows the current map and player position, so it requests a save. Game session owns journey state, schema validation, file replacement, and loading. Disk stores plain JSON. Content catalog converts stable species IDs back into current resources. The title and HUD only present derived state. Scene nodes, buttons, and labels never become the save format. This separation lets the save survive scene rebuilds and future art changes. Save only facts required to rebuild the journey. Schema 1 stores version, starter ID, an array of party members with species ID and current health, story flags, current map, and 2 position numbers. It does not store resource objects, scene nodes, a battle controller, an open dialog line, label text, focus, or UI visibility. Saving facts instead of presentation keeps the format small, readable, and independent from the current scene tree. Open creature_instance.gd. Add to _dictionary. If species is null, return an empty dictionary. Otherwise, return species_id as a string and current_health as a number. Do not copy the species name, field note, art path, affinity, or moves into every slot. On load, content catalog resolve the stable ID to the current resource. Corrected text or art can then improve without rewriting old saves. In game session, add a save completed signal with success and message. Add one user path constant and schema version 1. Store current map and player position as journey state. Also add save path override. Godot maps user:// to a writable application data folder. The override lets tests use a disposable slots so they never touch the player's journey. Project. Open user data folder opens the real location when you need to inspect it. Update reset new game before writing any file code. Clear starter ID, party, story flags, current map, and player position. Every persisted field needs an explicit new journey default. If one field is forgotten, new journey can inherit a location or flag from the previous session even though the disk code is correct. This is why ownership lists are useful. They become reset checklists and test checklists. Build a plain dictionary from current state plus the requested map and position. Convert string names to strings. Convert vector2 to a 2-number array. Ask each party member for its small dictionary. Copy story flags as names and booleans. Do not update current map or player position yet. The candidate describes what we want to commit. Live state changes only after the verified write succeeds. The normalizer is the heart of this lesson. It accepts only version 1, a known map ID, exactly 2 finite position numbers, 0 or 1 party member, a known species ID, health from 0 through that species maximum, consistent starter and party data, and Boolean story flags. Reject the complete candidate when any rule fails. Do not skip one bad companion, clamp impossible health, or preserve the fields that happen to look valid. Partial acceptance creates a new journey the player never saved. Validation should return a normalized snapshot, not merely true or false. The normalized output converts every accepted field into the exact runtime types the loader expects. This gives the writer, primary reader, backup reader, and repair path one shared contract. If different paths interpret JSON differently, a file may pass continue but fail during load. One normalizer prevents that split. The writer first creates the directory when needed. It writes JSON to save.temp, flushes, and closes the file. The primary slot is still untouched. A crash or full disk at this stage may leave a temporary file, but the previous primary remains available. Never remove the known good primary before the candidate has even reached disk. Read the temporary file back through the same parser and normalizer used by continue. Check file open, JSON parse success, root dictionary type, and the complete schema. This catches truncated writes and type changes before replacement. Verifying the in-memory candidate is not enough. The transaction must verify the bytes that were actually written. Before replacement, validate the current primary. Copy it to .back only when it passes the current schema. Do not override a good backup with corrupt primary bytes. The backup represents one older known good journey, not simply the previous file name. That distinction makes corrupt primary recovery meaningful. After the temporary file verifies and the valid old primary is preserved, remove the primary and rename the temporary file into place. If replacement fails after removal, copy the known good backup back when possible. This is not a promise that every file system rename is perfectly atomic. It is a small inspectable transaction with verification, backup timing, and bounded rollback. Save game builds the candidate and calls the writer. Only when the result says success does game session update current map and player position. Then it emits one player facing result and returns the Boolean. This order matters. A failed file operation must not make live memory pretend the save succeeded. The toast and continue button should follow the same returned truth. Has save must validate data. File exists is too weak because a 0-byte file, damaged JSON, unsupported version, or impossible party could still exist. Read and normalize the primary. If that fails, read and normalize the backup. Continue is enabled only when at least one complete snapshot is valid. The title screen now communicates a trustworthy promise instead of guessing from the file system. Load game follows the same boundary. Validate primary. If it fails, validate backup. If both fail, return false before changing starter, party, flags, map, or position. Only a complete normalized snapshot may rebuild live state. Apply it in one controlled function and emit one refresh. This prevents a damaged party from mixing with a valid-looking map or flags. When backup recovery succeeds, Attempt to repair the primary from that known good normalized snapshot. Report that the older journey was restored and repaired. On the next restart, the primary should load normally. The repair uses validated data, not the corrupt bytes. If repair fails, the live restore can still succeed and the backup remains evidence. Under UI layer, add title panel after the other interfaces so it draws on top. Build a full background, heading, centered card, subtitle, new journey, continue, and a short local save note. On ready, disable player control, hide the HUD and party panel, show the title, set continue from game session as save, and focus new journey. Movement, interaction, and party input must do nothing behind this panel. New journey resets game session first, then hide the title, show the HUD, set game active, and load starter village at the default spawn. This route never reads old disk state. If the player wants to preserve a damaged slot for support, they should copy it before starting over. Our one-slot UI stays simple and honest. Continue calls load game before changing the screen. Only success hides the title and activates the world. Expand load map with a use saved position boolean. A normal doorway uses its authored spawn marker. Continue uses game session player position. Without this explicit switch, the correct map can load while the normal spawn silently overwrites the restored coordinates. Add a save button to the world HUD and a hidden toast label. Save passes current map ID and player position to game session. Show success in soft green and failure in soft red for about 2.8 seconds. After success, recalculate whether continue is available. Hide world save while battle UI owns the screen. Schema 1 does not claim to restore an in-progress battle. Stop and restart the project. Continue should now be enabled because the complete slot validates. A malformed file must not produce the same presentation. This is derived UI. The button reads a trusted query and stores no separate save, exists boolean. One source of truth prevents the title and loader from disagreeing. Choose continue. Confirm the bondhouse loads. The explorer appears at the memorable saved position. Companion says real fin. Waymark says hearth. Party resolve remains correct. And Sola uses reward dialogue. This is the human proof that the snapshot rebuilds player. Visible meaning, not just a dictionary in a test. Validate save restore uses a temporary user path. It proves a one save, a separate reader, valid continue detection, corrupt primary fallback to .back, primary repair, structural rejection, and no partial mutation after failure. The separate reader matters because reading state back through the same live object can hide missing serialization. Test the disk boundary, not only the builder. Run the save test first, then all earlier gates. Content IDs must still resolve. Starter selection must still build one valid companion. Complete battle and Waymark delivery must still work. Persistence touches central journey state, so earlier behavior is part of its contract. A green focus test with broken gameplay is not a finished chapter. For the manual recovery drill, stop the game and copy primary plus backup to a safe folder. If no backup exists, make a second valid save first. Replace only the primary contents with not valid JSON. Restart. Continue should remain enabled because the backup validates. Loading should restore the older state and repair primary. Never practice corruption on the only copy of a real journey. If continue restores the wrong map, inspect current_map in JSON. Confirm the save button passes current map ID. Confirm load game applies the normalized ID. Confirm continue passes that restored ID into load map. Follow one fact across the ownership chain. Do not add a second last map variable to patch the symptom. If the map is right but position is wrong, inspect the two saved numbers and confirm they are finite. Confirm load applies game session player position. Then confirm continue calls load map with use saved position true. A doorway should remain false. One explicit root switch is clearer than guessing whether a zero vector means continue. If party state is empty, inspect species_ID and run content validation. The normalizer rejects an ID that no longer exists. Check current health against the species maximum and starter ID against the one party member. Do not silently load an empty party around a damaged entry. Failing clearly protects the meaning of the save. If invalid JSON crashes or clears progress, verify the reader checks file open, parse result, and root dictionary before normalization. A failed primary read must try the backup. If neither validates, return false without applying or overwriting session state. Keep player-facing messages separate from diagnostic details so the UI stays understandable while logs remain useful. Save once before choosing a companion. Stop and continue. The village and position should restore with an empty starter and empty party. This is valid early game state. A known empty starter with an empty party, or a party member that does not match starter, is invalid. Strict validation does not mean every field must be filled. It means combinations must make sense. If you use an AI assistant, name the owner, exact file, schema, accepted fields, rejected conditions, transaction order, and required test. Forbid cloud sync, encryption, multiple slots, scene loading, and UI. Review the returned diff in this order: normalizer, temp reread, backup timing, replacement failure, load fallback, state application, and messages. AI can accelerate the bounded implementation. You still own the contract and evidence. Use project. Open user data folder and inspect the JSON after one save. Confirm it contains IDs and plain values, not scene paths or personal account data. Keep the save outside the project. Never include your personal user folder or test slot in the recovery zip. The downloadable checkpoint should contain authored project files only. Close and reopen the Chapter 12 copy. Run all 5 validators. Perform one real new journey. Save, complete application stop, restart, and continue. Confirm the visible world facts. Then preserve the authored project as Glimmergrove_ch12_saved_slice. A checkpoint is ready only when automated and human evidence agree. This architecture scales. Settings can use a smaller schema. Multiple slots can wrap the same validated snapshot. Cloud profiles can transport the same canonical data through authenticated APIs. Multiplayer can keep server, authoritative progression, and serialize approved player facts. Those are later layers, not reasons to weaken the local foundation. Stable IDs, strict normalization, verified replacement, and apply after success remain useful. You now have a local journey that survives restart, rejects malformed state, recovers from one valid backup, and gives continue an honest meaning. In episode 13, we test extensibility from another direction. We will add one new move as data, make it load, appear, and resolve, and prove battle controller plus battle screen require no edits. Use the finished Chapter 12 download below if you want a clean starting point.